Hello students, welcome to Educate. In this class, we will discuss about the various units, and actually the chemistry starts from here. Not only chemistry, the science starts from here. So already you know there is 7 fundamental units. In physics, you will study in detail. Here in chemistry, you will not have to study in so much detail. So there is 7 fundamental units. What is fundamental units and what is derived units? About that you will study in the physics. So here 7 fundamental units. In that case, so there will be 7 unit. First one, length. Okay, there is 2 types of system. One is MKS system. MKS, that is meter, kilogram and second. One is MKS system, another one is CGS system. In CGS system, that is centimeter, gram and second, 2 system. And there is some difference, that is here, and most is SI system. Okay, SI system. So all the fundamental quantities has been included in the SI system. International system it is SI. Okay, international system. So length. So length SI unit is meter. Okay, and not the kilometer. So mass is kg. You know already that is time in second. Electric current. Guys, keep in the mind that electric current is the fundamental quantity and not charge. Electric current you have studied. Electric current I equal to Q by T. But the SI, that means fundamental quantity, is electric current. Same thermodynamic temperature, Kelvin is the SI unit of thermodynamic temperature. Amount of substance, that is mole. Amount here will mean the number of particles. So amount of the SI unit of the amount of substance is mole. And another one is luminous intensity. The SI unit of luminous intensity is candela. Okay guys, that is. Now let's see. Okay, how the length has been defined, how the mass has been defined. So length here, that is based on, the length is based on the velocity of light. And you know the velocity of light is 3.8 into 10 power 8 meter per second. Here for the convenience we write the 3.0 into 10 power 8. Sorry, 3 into 10 power 8. That is, so for simplicity we take 3, but actually this one is that much. In 1 second, light travels that much second. For the convenience of the calculation, we convert them into, because this one is approximately equal to 3 into 10 power 8. So that's why we take 3 into 10 power 8. So that much. So light, when so light is here defined as here, this length, that is here light traveling that much, that is called in that much second, how much did it define, that is called length. Then after is unit of mass. Mass, there is a fixed, their weight, fixed numerical value of Planck's constant h to be this much. Unit of time, that is oscillation, based on the oscillation. So cesium, 1 second here, that is taken by the cesium clock. Okay, for the time, cesium clock, this one important. Electric current, what is that? Force of attraction operating between the two particles, between the two wires fixed at this one. Thermodynamic temperature, this one here, and so that means you have to just study this one. Once you will study, you will understand what is that. Then after is mass or and weight. So about the mass and weight, you know already what is that mass here. Volume also very simple. When I was in 7th class, then I was confused. Anyone have not told me that what's the unit, what's the difference in area and the volume. Let's see here, area and volume. Area is a two-dimensional quantity. Suppose when you will have to find out the area of this substance. So area of this substance will be this one, from here to here, plus here to here, plus here to here, plus here to here. That means at surface area, you keep all this one, like this one, then after this one, then after this one, then after this one. So when you will add them totally by this one, then that we call the area. And volume, how much inside this one, how much space is there, that is volume. Okay, simply teacher tell to find out the formulas and so on, but actually the meaning of area is how much this one here, two-dimensional quantity it is. So when you will have to find out the area of this portion, so that keep this one, then this one, then after this one also, then this one also. So continuously add them, this one also, and so on. And volume means this portion, how much water you can keep, or like that, how much space it's acquired, that is volume. Okay. Uncertainty in measurement, that you study in the physics. Now we just start from here, mole. Significant figures you calculate, you find out in the physics. In the physics you will study in detail. So here main chemistry starts from here. Law of chemical combination. From here the chemistry just starts, and question also asked from here, that is law of chemical combination. First one is law of conservation of mass. Law of conservation of mass states that during a chemical reaction, total mass of product will be equal to total mass of reactant. That is law of conservation of energy, and everyone know that means the energy can neither be created nor destroyed. Same way here, about mass. So mass will neither create nor destroy. So that is here in the generalized way it is. But you know already there is an interconversion of mass and energy, that is E equal to mc square. You know that is mass can be converted into energy and energy can be converted into mass. But in our day-to-day life, we don't consider there. So here that is and here during chemical reactions there is no conversion of mass into energy. So mass will convert into energy or the energy will convert into mass when the velocity of substance will be comparable to the velocity of light. Practically that is not possible. Maximum velocity is the velocity possessed by the light. So here acquiring that much velocity practically not possible till today. So that's why here these laws are valid. The first one is law of conservation of mass, that was given by this law of conservation of mass that was proposed by Lavoisier. So the students who is preparing for the CUET examination and NEET examination, he will have to keep in the this is some information like who have defined the law of conservation of mass, who have proposed the law of definite proportion, and so on. So first one is law of conservation of mass. Its law of conservation of mass states that during chemical reaction, mass will neither created nor destroyed. So guys, we balance the chemical equation in 9th, 10th classes. You are aware that when we write the chemical equations, we balance the chemical equation. Why? Because during the chemical reactions, mass neither create nor destroy. So we will by the balancing of the chemical equation, we make the mass of reactant equal to mass of product. Since during the chemical reaction, the mass will neither create nor destroy. So that means the mass of reactant will be equal to mass of product, and that was proposed by Lavoisier. Then after is here law of definite proportion. Law of definite proportion, that was proposed by Proust. That was proposed by Proust. Law of definite proportion, and that is also called law of definite composition. Law of definite proportion, or law of definite proportion, or the law of definite composition. This law states that whatever be the source or method of preparation of a compound, whatever be the source or method of preparation of a compound, the ratio of the constituent elements of a molecule will be always constant. That means in water here, so water you separate from the sea or from the river or from mountain, from anywhere you obtain, or you prepare by any method, like a combination of hydrogen and oxygen, by combining hydrogen and oxygen, or by the reacting with of acetic acid with the ethyl alcohol, like that. By any method you prepare, the ratio of hydrogen and oxygen will be always constant. Like here H2O here, so ratio will be always 2:16, that is 1:8. So whatever be the source or method of preparation of a compound, the ratio of the constituent elements will be always constant. That is here the given compound always contains exactly the same proportion of elements by weight. That is here. So I have told you here in the detail, here it has been written in the short. Then after is law of multiple proportion. Law of multiple proportion, that was proposed by Dalton. Law of multiple proportion. And law of multiple proportion is valid when two elements combine to form two or more than two compounds. When two or more than two compounds form, when two or more than two compounds form by two elements, then their ratio will be always constant. Let's see here as an example. Through the example we discuss. From here, sometimes question was asked about that. We will discuss about this question, exercise questions also, but in the last here, because I will have to go further, so that will take time. So here we firstly I make you acquainted with the concepts, and then after the which type of questions asked. Yeah, that means numerical questions asked in the NCERT book is there. About that we will discuss. So firstly, let's see here hydrogen here. When hydrogen reacts with oxygen, it is in the NCERT book example. So there is formation of H2O. So here it is 2. This one, when hydrogen will react with oxygen, then there is formation of another compound that is called hydrogen peroxide. Okay, so here listen, in this case, in water, the concepts which I am telling you, if you will apply that concept, then the question which asked in the examination in the twisted form, that you can solve. Okay, I shall also guide you how to solve that type of question, and which type of question asked in the examination from this concept. But right now you just watch out how we will have to solve the question. Okay, so let's see here. So what is happening here to H2O in this case? So its atomic weight of hydrogen is 1 and atomic mass is also 1. So here total is 4 gram hydrogen react with 32 gram oxygen. So 4 gram hydrogen reacts with 32 gram oxygen, or better you write hydrogen, because maybe someone will get confused by atom or molecule. 4 gram hydrogen reacts with 32 gram oxygen. So 1 gram of hydrogen will react with how much? 32 upon 4. That means 8 gram oxygen for this reaction. Now watch out on this reaction. Here 2 gram oxygen hydrogen reacts with 32 gram oxygen. 2 gram hydrogen so 1 gram hydrogen will react with how much? That is 16 gram oxygen. So ratio of oxygen in here and here, that will be a simple whole number ratio. So ratio of oxygen in okay, that is when two elements combine together to form two compounds, then the ratio of a particular element which combines with a given amount of or a definite amount of other element will be always a simple whole number. When two elements combine together to form two different compounds, then the ratio of an element which combines with definite amount of other compound with definite amount of other element will be a simple whole number ratio. This one clear? Another example also I will take, that is I am taking about the SO2 and SO3. When sulfur combined with sulfur S only we write, but actually that is S8. So when sulfur combined with oxygen, there will be a formation of SO2, and when sulfur combined with oxygen, there is also formation of SO3. So what happened? 32 gram of sulfur, 32 gram of sulfur combines with how much? 32 gram oxygen. Oxygen combines with or reacts with? Combines with 32 gram oxygen. So 1 gram of sulfur will react with how much? 1 gram oxygen. In the same way, now in this equation, 32 gram of sulfur react with how much? 32 gram of sulfur react with how much? Okay, balance this equation. So 64 gram of sulfur combines with how much? 64 gram of sulfur combines with whatever with that you multiply by yourself. So 1 gram of sulfur will combine with how much? So as it is 3.2, that means 1.5. No, 1.5. So ratio of sulfur, that means ratio of oxygen which combines with 1 gram of sulfur will be how much? 1:3/2, that means 2:3. that is, which is a simple whole number ratio. It will be always a simple whole number ratio. That means that will be in the fraction. That means it will be not like 1 by 1 upon 3 and like that, 1.33 like that, this one. So that is here. So in the examination, one question is here that's numerical based, that there will be data will be given and will ask so that this equatorial reactions follows law of multiple proportion. Okay, and another way of asking the question is that will be given, and here that will be, okay, one is who have proposed, that's for the CUT examination question may ask like that. Next one is Gay-Lussac's law of gaseous volume. Gay-Lussac's law of gaseous volume, that means this law is applicable for the gaseous reactant. That means when gases reacts and form the gaseous product. In that case, the Gay-Lussac's law of gaseous volume asks. Okay, so what is here? Gay-Lussac's law of gaseous volume tells that. So Gay-Lussac's law of gaseous volume states that during the chemical reaction, the ratio of the volume occupied by the gaseous reactants, the ratio of volume occupied by the gaseous reactants as well as of any one of the reactant and the product if will be a simple whole number ratio. Will the ratio of the volume occupied by the gaseous reactants as well as any one of the gaseous reactant and the product will be always a simple whole number ratio. Okay, now that was about Gay-Lussac's law of gaseous volume. Then after is Avogadro's law. Avogadro's law, that is here, Avogadro's law you know already, that at the same condition of temperature and pressure, Avogadro's law states that at the same conditions of temperature and pressure, at the same condition of temperature and pressure, 1 mole of any gas, okay, equal number of moles of any gas will occupy equal volume. So in other words, the Avogadro's law states that when there is 2 container, okay, I am writing here, then might be you feel difficulty. So here this volume here and here is, if its number of moles of gases in this case and this case will be same, temperature of this container and temperature of this container will be same, and the pressure exerted on the wall of the container, that will be also same. That means when the number of moles of gases will be same, the temperature and pressure of that gas inside the container, that will be also same, then the volume occupied by the gas will be also same. Or if volume here is fixed, if volume of this container is and this container is equal, if the volume of this container and this container is equal, pressure inside this container and this container will be equal, temperature inside this container and this container will be equal, then same number of moles, then number of moles of the gaseous particle in this container and this container will be equal. Avogadro's law states that when the temperature, pressure and volume of here, when the temperature, pressure and the volume occupied by the gas will be same, then number of particles of the gases will be also same. So Avogadro's law states that at the same conditions of temperature and pressure, equal number of moles of gases will occupy equal volume. Okay, that was here. Okay, but then after is about the polyatomic molecule and diatomic molecule. Polyatomic molecules means that molecule will be made up of a number of atoms. So that will be called polyatomic molecule. Means in that molecule there will be a number of atoms. And diatomic molecules means in that molecule the number of atoms will be 2. That is, so that will be the diatomic molecule or the polyatomic molecule if the conditions of temperature and pressure and the volume are same. if the conditions of temperature and pressure will be same and the volume of the two gases will be same, then the number of particles, that means number of molecules of both the gases, will be equal. Okay, that is called by the Avogadro's law. Okay guys, this one here, that is during the chemical equation, here volume of the hydrogen is 1, here volume of hydrogen 1, volume of oxygen 1. So this one here, 2 volumes of like H2O. Let's see here. So here 2 is here 1. So volume occupied by this one, suppose volume occupied by 1 mole gas is X. So during the equation, there is 2 moles of gases, so 2X. So this volume and this volume will be X. Then the final volume will be 2X. That is still 2 volume here, its volume is suppose X. So X volume plus X volume, and this one also X volume. Total volume 2X, not 3X. Okay, this one states that because the hydrogen and oxygen combine to form, that means 2 moles of hydrogen, 2 moles of hydrogen molecule combined with 1 mole of oxygen molecule, so form 2 moles of H2O. So according to the equation, the volume will occupy. Okay guys, it's all for this class. In the next class, we will discuss about the few questions asked on the basis of this concept, and then after we will start Dalton's atomic theory. Okay, so it's all for this class. Thank you, Team Educate.